Hi, this is Mrs. Barbara. This is Regents Physics Chapter 2, Video 8. Today's lesson is Newton's second law, Part 2. The objective for today is to be able to determine acceleration at force and/or mass, use the acceleration at force, applied force, or friction force to determine unknown quantities. Basically, is to apply Newton's second law. Let's take a look at our first example. As represented in the diagram below, a constant 50 Newton force F is applied to a 2.5 kilogram box, accelerating the box to the right at 2 meters per second squared across a rough horizontal surface. 1. Calculate the magnitude of net force acting on the box. 2. Determine the magnitude of force of friction on the box. So whenever you have a question like this, the first thing you do is to draw a free body diagram. So here is here are the forces acting on the object. You have applied force of 50 newtons. You also have gravity, which equals mg. We know the m is 2.5 kilograms, so we can figure out what gravity is. Once we know the gravity, we can figure out the normal force because the car is only moving in the horizontal direction. In the vertical, it's in equilibrium, so the two forces cancels out. The other force, we know you'll have a force of friction because it's a rough horizontal surface. Next one, you write down what you know. M equals 2.5 kilograms, applied is 50 newtons, acceleration is 2 meters per second squared to the right. So to the side of applied force. Calculate the net force. Well, net force equals to MA, so straightforward. 2.5 times 2 give you 5 newtons. Number 2, determine the magnitude of force of friction on the box. So you may think force of friction is mu times Fn, but you don't know mu. So you can't use that equation. What is another equation will give you force of friction? The other equation is the net force. Remember, net force is the sum of the forces. So net force is applied plus negative friction, or net force is applied minus friction. Net force we already know, 5 newtons. Applied force is 50 newtons. And you can solve for friction is 10 newtons. Obviously, it's to the left. Another example. A horizontal 20 Newton force is applied to a 5 kilogram box to push it across a rough horizontal floor at a constant velocity of 3 meters per second to the right. So here is a key word is constant velocity. Here is a free body diagram. What does constant velocity mean? That means acceleration equals to 0 and the net force equals to 0. That means up and down has to cancel, left or right has to cancel. A. Determine the magnitude of force of friction. Since it's moving at a constant velocity, force of friction and applied has to be the same. So force of friction equals to 20 newtons. B. Calculate the weight of the box. Weight of the box is gravity equals to mg. So m, we already know that's 5 kilograms, g is 9.81, so we have 49 newtons. C, calculate coefficient of kinetic friction between the box and the floor. Coefficient mu is Ff over Fn. Ff is 20 newtons. From part A, Fn is from part B, so we have 0.41. Remember, mu has no unit because Newton cancels. Mu is just a ratio of numbers. Next example, the diagram below represents 4 Newton force applied to a 0.2 kilogram copper block sliding to the right on horizontal steel table. So what does this tell you? Applied force is 4 newtons. The mass is given to you. Another thing given to you is the type of surface. It's copper on steel. That means you can find mu from your reference table. Here is the free body diagram. Applied force is 4 newtons. Again, up and down should cancel out because the copper block is not moving in the vertical direction. And the other force is force of friction. A, determine the weight of the block. The weight of block is gravity equals to mg. W equals to mg 0.2 times 9.81, so you have 1.96 newtons. B, calculate the magnitude of force of friction acting on the moving block. Now you can use force of friction equals to mu times Fn because you know mu. Where do you find mu? From the reference table. So what is Fn first of all? Fn and Fg are the same. So Fg is 1.96, Fn is 1.96. Ff equals mu times Fn. This is from the reference table. It's copper on steel. It's kinetic because it's moving. So you should have 0.71 newtons. Determine the magnitude of net force acting on the block. There are two ways to figure out the net force. One way is net force equals ma. So if you know the acceleration, you can use that equation, but we don't know acceleration. The other equation is net force equals the sum of the forces. That means it equals to applied force plus negative friction. Why it's negative? Because it's going to the left. So it's a 4 minus 0.71, you have 3.29 newtons. Net force is to the right. It's in the same direction as velocity. What does that mean? Because describe what happens to the magnitude of velocity of the block as the block slides across the table. Because there is a net force acting on the block to the right, in the same direction as velocity, that means the block will accelerate to the right. So as a result, the block's velocity will increase to the right. Another example, a student and the waxed ski he's wearing have a combined weight of 850 newtons. The skier travels down a snow-covered hill, then glides to east across snow-covered horizontal surface. This is a free body diagram. So on this student, there is gravity, there is normal force, the other one is friction between the snow and the ski. The student is not exerting any force. 1. Determine the magnitude of normal force exerted by the snow on the skis. The normal force should be equals to gravity because there is no motion in the vertical direction. Gravity is 850 newtons. Normal force is 850 newtons. 2. Calculate the magnitude of force of friction acting on the ski as the skier glides across the snow-covered horizontal force. Again, force of friction you can also calculate in two ways. Force of friction equals mu times Fn, or force of friction could be calculated from net force and other forces. So in this case, do we know mu? Yes, we do, because it's waxed ski on snow. So look at your reference table. You can find mu equals to 0.05, and we already know Fn, so the answer is 42.5 newtons. Another example. So a manufacturer's advertisement claims that their 1,250 kilogram or 12,300 Newton. This is the weight of the car. This is the mass of the car. Sports car can accelerate on a level road from 0 to 60 miles per hour, 0 to 26.8 meters per second. So this is converted 60 miles per hour to meters per second. In 3.75 seconds, determine the acceleration in meters per second squared of the car according to advertisement. Acceleration is change velocity divided by time. Change velocity is 26.8 meters per second. Time is 3.75 seconds. So your answer should be 7.1 meters per second squared. Calculate the net force required to give the car this acceleration. Well, net force equals to ma. So here's m and a. You'll have 8930 newtons. What is the normal force exerted by the road on the car? Normal force and gravity should be the same. So normal force is 12,300 newtons. Question D. The coefficient of friction between the car's tires and the road is 0.8. Calculate the maximum force of friction of the car's tire and the road. Well, force of friction equals mu times F normal. Mu is given to you 0.8, normal force is 12,300 newtons. So the answer is 9,840 newtons. Using the value for the forces you have calculated, 8930 and 9840, explain whether or not the manufacturer's claim for the car's acceleration is possible. Well, to accelerate a car from 0 to 60 miles per hour, like the manufacturer claimed, a net force of 8930 newtons is needed. So that's how much force is needed. Since the friction produced by the road and tire is 9840 newtons, the friction alone will be able to accelerate the car at the stated rate. Really is decelerate the car at more than that, 7.1. So the manufacturer's claim is possible, although it has nothing to do with the ability of the engine, because the acceleration is made possible between the tires of the car and the road. That's it for today. Thanks for watching. See you next time.